Hello everybody. So today we're going to learn something called calorimetry. And if you listen to the word, you might hear the word calorie in there. And so this is actually to do with energy and calories because that's why we eat food. So the law of conservation of energy says that energy cannot be created or destroyed. We can transfer it, but it has to go somewhere. It can't get lost. It can't disappear. So what we do in calorimetry is we measure the change in energy of an object. So how much energy went in or how much energy came out, how much energy was transferred. That's what calorimetry is. And again, it has that base word of calorie because that's going to have to do with how we measure the energy in a minute. Now, this is all to do with something called specific heat. And like it says in the name, specific heat has a very specific definition. So it says it's the amount of energy required to raise the temperature of 1 gram of substance by 1 degree Celsius. So this is like if I was cooking, and when I am stirring something, I use a wooden spoon because even if I put a lot of energy into that wooden spoon, it's not going to change its temperature very much and I can still hold it in my hand. It has a high specific heat. It takes a lot of energy to change the temperature of that wooden spoon. But we don't use a metal spoon because you're going to burn your hand. If I just put a little bit of energy into that metal spoon, the temperature is going to go up by a lot. It has a low specific heat. With just a little bit of energy, the metal will heat up a whole lot and burn my hand. So it's the different spoons that we use to cook our food. That's what specific heat has to do with. So what I want you to get in your head is the lower the specific heat, the less energy is required for a substance to change temperature. Okay, so a low specific heat is something like a metal spoon. You give it a little bit of energy, it will heat up a lot. A wooden spoon has a high specific heat. It takes a lot of energy for that to change temperature. Okay, so we're going to be measuring things. So we're going to have all these different variables today. So we're going to work on all of these different letters. So we're going to use Q as the variable to be heat or energy. Heat and energy mean the same thing. Okay, there's two different options for Q. We could measure Q in joules, which we abbreviate with a J, or we can also use calories because this is calorimetry. Calories is a measure of energy. So you can use joules or calories. You won't have to guess. There will be a clue in the question. Now, M we're going to use for mass. We've dealt with mass before, and we measure mass with grams. Now, C is kind of tricky. C goes back to that specific heat definition from before, okay? So C is the abbreviation for specific heat. I know it starts with an S. I didn't make it up. Sorry. So specific heat, because it has such a specific definition, also has a very specific and tricky unit. You're going to identify the specific heat because it's going to say joules / grams degrees Celsius. That whole thing tells you that a number is specific heat. Okay, now because the other thing that I can have for energy, I could have joules or I could have calories. Another option is I could have calories per grams degrees Celsius. So whenever you see that big long specific unit, your number is the specific heat. Okay, now the last one is not triangle. Okay, we pronounce that triangle as delta, delta T. Okay, so, Okay, so that triangle we really pronounce as delta. And so this really means the change in temperature. Okay, so delta T or change in temperature. That delta is the symbol for change in. Now to measure how something changes, what that means is that we're going to subtract temperature. So you're going to probably get two temperatures and you're going to have to subtract them. Temperature is something we're familiar with. It's going to get abbreviated with degrees Celsius. What I want you to be careful of is degrees Celsius goes with temperature. That C over here is different than this C of specific heat. They are not the same thing. I know that's very confusing. I didn't make up this system, sorry. So big C means specific heat, okay? Then the delta T, the change in temperature, has the unit of degrees Celsius. So be really careful that you know which one is which, all right? All of these variables get put together into this formula that we're going to say Q equals MCAT, okay? So Q, the heat or energy, equals mass times specific heat times the change in temperature. So we're going to do several problems as examples and do some practice here. Okay, and we're going to use this same math formula every single time. So the first thing I'm going to do before I even read the question, I know that I am going to be using, there we go, Q equals MCAT. So I'm going to write that formula because I'm definitely going to use it to solve this. Then you might want to grab a highlighter. We are going to be looking for some numbers. Okay, I see a 40, I see 10.00, 30.00, and then I see this over here. So we have to list all of those numbers and figure out what's what. So I see this 40.0, and because it has the G on it, grams is the unit for mass. So this number is my M. Now over here, the next two numbers, both of them have degrees Celsius on it. So that must mean I have to subtract them. We're always going to do the bigger one first so that we don't get a negative number. If you get a negative number, just drop the negative sign. So 30 minus 20 equals, or 30 minus 10 equals 20. Because I have degrees Celsius on that number, that must be my change in temperature. Over here, I see this really big specific unit, joules/gram degrees Celsius. That tells me that the 4.18 must be my C, specific heat. Now, if I look back at my formula, the only thing that I don't have is the Q. And if I double check the question, it says determine the energy. So I must be solving for Q. So now we just have to put all of the pieces in. So do I have a Q? No, that becomes X. And then I'm going to put equals. Now, M, I already figured that out. That is 40.0. I'm going to use parentheses here to show that we're multiplying these numbers together. Next, I want the C. C is 4.18. Then the delta T I subtracted is 20. So really, all we have to do is multiply these numbers together. Nice and short and sweet. So 40 times 4.18 times 20. And so I get 3344 is my calculator answer. But of course, sig figs, I told you they're not going away, and I meant it. Let's go back to everything in the question. There were 3 sig figs here. There were 4 sig figs here, 4 here, 3 here. If you have a choice for sig figs, I want you to choose the lowest option. So up here where I have 3 and 4 sig figs, I want my final answer to have 3 sig figs because that is the lowest option. Okay, the third sig fig over is right here at that 4. So keep the 3 and the 3 in the front. Then this 4 is going to stay because of the 4 after it. This other 4 has to turn into a 0 so that it's 3,000 and some change, okay? Lastly, we were solving for Q. That's what we figured out over here. Q has 2 options. Q can be joules or calories, but I can't just pick my favorite. There's a clue up here in the question. If I read back through all of that, I see a joules hidden right here. Because joules was given in the question, that's what I am going to put onto my answer. Okay. This next one is not a math question. This one says, which of the following will require the largest amount of energy? Now, if I look down here at all of the choices, okay, they all say 10 grams, so that must not be important. And they all say 10 degrees Celsius, so that must not be important. The difference is that they all have different C values. Now, if you remember from our chart up above, C means the specific heat. Okay, and so what we are looking for is which one will require the largest amount of energy. We want something with a really large specific heat. The biggest specific heat that I see is letter A. So the answer is A, because water has the largest specific heat. So large specific heat means it takes a lot of energy to change temperature. All right, let's go back to a math question quick. All right, so I am going to write down my formula again. We're going to use Q equals MCAT. Then I'm going to get my highlighter and I'm going to go searching in the question. I see a number here. It's scientific notation. Don't be afraid. You can do it. I see some numbers here. I see another one here. So let's figure out what we got. Okay, this first number says joules. So it's 3.00 times 10 to the third. If something is joules, that means that it is a Q. Next, I see two things that say degrees Celsius. That must mean that I subtract them. Remember, do the bigger one first. So 70 minus 35 is 35 degrees Celsius, and degrees Celsius is our delta T. Then I see this right here, that really big specific unit. That is the unit for C, our specific heat. The thing that they didn't give us was the M, the mass. If I double check the question, it says, what mass of copper? So I'm going to solve for M. All right, so let's see what we got. The Q is this number. That thing in scientific notation, we're going to use the E for that in a minute. Equals M. I have no idea what that is, so I'm going to put X. And I'm putting it in parentheses because we're going to multiply things. All right, do I know the C? Yes, I do. It's 0.386. Delta T we calculated is 35. Okay, so I'm going to leave this side alone. I'm not ready to deal with that yet. On the other side over here, I'm going to combine my like terms. I'm going to multiply these two numbers. So 0.386 times 35. So I have 13.51x. To get x by itself, I'm going to divide by this, the thing that's touching the x. Remember, when you put this one in your calculator, you're going to do 3E3. Okay, that's how we put that scientific notation into the calendar or calculator. Divided by 13.51. So my calculator answer says 222.057735, blah, blah, blah. And of course, we're going to do sig figs. They're really not going away. There were 3 sig figs here, 3 here, 3 here, 3 here. Everything had 3 sig figs. I must need 3 sig figs in my answer. The third sig fig over is right here at this 2. So my answer becomes 220. Because there's a 0, I'm going to leave it 222. You can put a decimal or not. In this case, it doesn't matter. And what was I solving for again? I was solving for mass. The unit for mass is grams. So that's what I have to put on my answer. All right, let's try one more. It's going to be Q equals MCAT again. Same formula. Grab your highlighter. Let's look for some stuff. Okay, there's a number. There's a number. There's a number. Let's figure out what they are. So this 200 says grams. Grams is the unit for M for mass. Then I see this 4.20 times 10 to the third, and that says joules. If something says joules, it must be a Q number. Over here, I see 0.128, and it has that really long specific unit on it of lots of things, so that must be my C value. The thing that I don't have is the delta T. If I double check the question, it says, what is the change in temperature? So that's the piece that I'm solving for. All right, so let's substitute in what we know. The Q, that's the first thing in my formula, so I'm going to write this 4.20 times 10 to the third equals, do I know M? Yes, I do. That's 200.0. Okay, do I know the C value? Yes, that's the 0.128. I don't know delta T over here, so I'm going to substitute in an X. I'm going to keep this side of the equation till I'm ready for it. I have to combine my like terms. I have to multiply 200 times 0.128, and I get 25.6x. To get x by itself, you divide by the thing touching the x. When you put this into your calculator, remember to do 4.2 E3. Don't forget your oath. All right, so 4.2 E3 divided by 25.6. So I have 164.0625, and of course we're going to check out our sig figs. So I had 4 sig figs here, 3 here, 3 here. That must mean I want 3, because remember, we're going to choose the lowest option. If I round my number right here to 3 sig figs, that's at the 4. So I keep it 164. The 0 means we're going to stay. Now, the thing we were solving for was the change in temperature, which has a unit of degrees Celsius. So my final answer here is 164 degrees Celsius. All right, so your job is to scroll down to the bottom of this page, flip the page, find the next set of problems, and I want you to try all of these questions. When you're done, come back here for the answers and you can compare with me. All right, let's see how you did. Did you do all of those questions? Let's see if you got them right. Here are the answers for the remaining questions. If you have anything to ask, something you can't figure out, go check in with your teacher. Good job, my dears.